Hi, my name is Aditya. I am the CEO of Automatski, and today I'm going to be showing you portfolio optimization with quantum annealers. Now, in all the demos that you would have seen so far, they peak at around 50 assets, portfolios of 50 assets. There is a hybrid quantum classical algorithm called QCHOP, which has done 250 assets over a 64 qubit trapped ion quantum computer. Now, what I'm going to be showing you today is pure quantum computing. There are no hybrid algorithms, there are no classical shortcuts, no heuristics. And even though some people will say that we are cheating and we are using heuristics or classical methods, that is why we have created a GitHub repository with the entire code base for you to have a look at. This GitHub repo is public and you can have a look at it, and there are instructions on how to run it and links to Automatski's both quantum SDKs for quantum annealing and quantum computing. Though you will not be able to run it because you will need access to Automatski's quantum annealer. So this is portfolio optimization. This is running on Automatski's quantum annealer. And the way it works is a pure quantum algorithm. It creates a QUBO, which is a quantum quadratic unconstrained binary optimization problem, which it executes over a quantum annealer. Now, Automatski's quantum annealers support more than 500 million uh, spin up and down or Boolean variables, as you call it. Yes, you heard that right. 500 million of those variables, and it takes only seconds to solve problems with 100 million variables. So, on my left, you have the server host and port, but ignore this because we have hardwired this to run over a VPN. And here you can choose the assets. You can give comma separated values of assets. I have put 10 values, and you can define the period or a date range to fetch the data and the level of risk that you want to uh, uh, accommodate. Because the entire idea behind portfolio optimization is that you have a portfolio of assets or stocks, let's say 100 of those, and you want to select a few of those with the maximum returns for a given level of risk. So here I'm selecting K assets to select as 4 because we have 10 assets in the portfolio anyway. So we can't select 10. And you can either go for a portfolio selection where all assets have equal weights, or you can select maximum Sharpe ratio, my minimum variance, etc. I have gone for maximum Sharpe ratio. So the assets that will be selected will be of weights that give me the maximum Sharpe ratio. Okay, so let's run this. That's it. You have 10 assets, selected 3, cardinality, unconstrained, weights, maximum Sharpe, expected return 33.61, equal weight, standard risk, Sharpe ratio, and here is the portfolio allocation for maximum Sharpe ratio. You can see the weightages for Google, JPM, and Apple. Now I'm going to set the number of stocks to 10 because I'm going to select from the top N US equities. So we have configured a list of 6,504 US equities that are available and we can optimize portfolios on. And I have run this portfolio optimization tool many times today. So the data has been cached already, unless I select stocks that have not been cached. Data caching is a huge problem because we are using public data sources. This is not a production grade system in the sense that it needs to be integrated with the trader's desk data sources, and we have not done that. But otherwise, in terms of computational accuracy, this is a production grade system. So I'm going to be showing you 1007 stocks. Some will throw errors, uh, will have data errors, but the rest will be analyzed for portfolio optimization over a 2 year period of previous data. Now, uh, let me run this. Yeah, that's how much time it takes. That is the Cubo Energy 963 qubits, 4 lakh 64 166 clauses dropped. Around 30-40 stock tickers were dropped because they had insufficient data. And here I have selected the selection of portfolio allocation. Here you can see the 10 stocks for maximum Sharpe ratio. Now, this is a production grade system. It is ready and it can be deployed today. It needs to be integrated with data sources, which the customers would already have, presumably, and it is good to go. It is running on Automatski's quantum annealers that can support up to 500 million Boolean variables. And for 100 million Boolean variables, the annealer has a timing of a couple of seconds. So this is really production grade, and that is all we had to show you today. Let me know if we can help you in any way. Thank you very much.